Okay, guys, my name is Luciano Arango. I'm a sophomore in Adam's house, and we're going to be talking about web security active defense. So I work for the Office of Information Security in C's, and over the summer I interned at SegurTech, which was a information security company that served for the Bank of Colombia. That's mostly where I learned what I've learned so far. And so some of the material that we're going to go over today we haven't really talked about in class, but we will soon. It's going to be like SQL, JavaScript, and we haven't really gone over it. So I'm going to sort of fly through it, and you might like not know some things, but soon you'll learn it, and it'll all make sense. Also, another thing, stay ethical. Some of the things that you learn you could use in non-ethical ways. If it's yours, definitely try. I definitely motivate you guys to try your own servers, try going inside them, see if you can penetrate them, if you can get inside them. But not anyone else's. Cops don't really like the jokes and the whole, like, we put this here, we're messing around. They get really angry. So head over to this website. I have it opened right here. Right, this is a website, and it has a bunch of examples. What happens is that the first example is sort of going to be a lot easier than the last example, in the sense that the first example is completely insecure, and the last one is sort of what a normal web security person would do, but you can still sort of get around that. And we're going to be focusing on 1 and 2, examples 1 and 2. Okay, let's start with cross-site scripting. Okay, so JavaScript is run on the client's browser. It's a programming language that you use to run on the client's browser, so you don't have to update the website and go back to the server. You have it running, like, for example, like Facebook. You don't have to reload the website for new status updates to come up. It's using JavaScript to generate all these things. So we can inject malicious JavaScript into the website, and that way, when we send this, sort of like a link to someone, we could sort of send it with some of the code that we want. There's persistent and non-persistent JavaScript. There's persistent, non-persistent cross-site scripting, I mean. And the difference being that persistent is JavaScript that will be saved on the website, and non-persistent will be JavaScript that will actually just happen once. So let's take an example real quick. So, okay, so this website, simple, just going, nothing happens here. And we're going to try to insert some JavaScript. So the way we start writing JavaScript is we start with the beginning script, and we close it with script. We're simply going to put a message. I'll show you. Alert. Alert is a function that JavaScript uses to display something. So let's try real quick. And we go alert hello. Well, I forgot to put. Okay, so that's simple. We put JavaScript in the website, and it came up. And it sort of only happens on our website, right? So it seems like it's not a problem, right? I mean, how could you use this maliciously? So the way that hackers do this is really simple. They're going to grab it. They can send this link to you, right? If I send this link to you right now and you open it up, it's going to say hello, saying that my website is telling you hello. And so if I were to say something a little bit smarter, if I pull up JavaScript function I kind of already wrote. But if you look at it, I'll go over it before I wrote it. So we're going to set a timeout, right? We're going to wait for a couple seconds. In fact, we're going to wait for, if I'm not mistaken, 5 seconds. This goes in milliseconds. And then what we're going to do is we're going to alert that the login timed out to log back in. And we're going to change the location to a different location. So if I send this website to someone, they're going to be browsing around, calm, nothing's happening. And in 5 seconds, it's going to say your login timed out. Please log back in. Once they click OK, I'm going to take them to another website. Presumably, the website is going to be a lot similar to the website that they were in before. And they're going to log the credentials into my website instead of their website. And so I can send people an email with this link. I say, oh, here's a link. If this is a bank, for example, I say, here, go on this link. And once they send it, they're going to be browsing around. I can wait for 15 seconds, 20 seconds, and then pop that, please log back in, sign back on. You guys can try with a lot more things. It's complicated because you guys haven't seen JavaScript, so you might not know some functions. But all you have to do is start with script, end with script, and you can put anything in the middle. Alert is a function, wait for window location takes you to a new location, but you can do so much more. And so the idea is that we take that off. If I go to example 2 and I put in the same code, it's not going to work. So it's printing everything out. Because what this website originally does is if I put anything here, it'll print it out right here. So it's not printing anything out. We're checking. This example is actually checking to see if script is there. So, yeah, go ahead. Ask me.
Is this not sending a get or post request?
Yeah, they're sending a get request.
It is.
Yeah. You can do. It's also like browsers use post requests, but I'm trying to show get requests so that we can see what is actually going on. And so if we look at this code, so it's not working anymore. And if we take a look at this code, it's going to be in example 2. What this person is doing, the person in charge of this browser, open up. Okay, is replacing the word script. This is PHP, which you guys might have seen a little bit of yet. He's replacing the word script with name. So, however, if I go ahead and just put in if I grab my code again and I'm going to modify it just a little bit, instead of script, I'm going to change it for script with capital R. And we're going to see if this code works. So it didn't print it out, which is a good sign. And hopefully in 2 more seconds, it's going to pop up. Your login timed out. OK, that's right. So checking for script might not necessarily work. The person, you can also check for script uppercase, script lowercase, stir case compare, make sure they're the same. But the hacker can still do sort of what we did in Visionaire when we move back a couple characters, move forward. And they can figure out how to put script back in there so they can inject that script. So what you want to use is HTML special chars to protect your website. And this, what this does is it makes sure that what you put in, for example, quotations or this greater than or less than, is replaced with something that won't be. Let me zoom in here. The actual ampersand. It will replace those special HTML characters that we see when we're talking about. When we see, oh, this is going to take me back to these characters right here. These signify that something is coming. For HTML, that beginning bracket tells us that something HTML related is coming, and we want to get rid of that. We don't want to put HTML into the website. We don't want the user to be able to put something in their website that can affect their website, like script or HTML or something like that. What's important is so that you sanitize the user input. So the user's going to input many things. He can input a bunch of stuff to try to trick your browser into still running this script code. What you want to do is not just look for script, but look for everything that could be malicious. And HTML special chars will do that for you, so you don't have to worry about it. But don't try to do it by yourself, sort of with your own code. Is everyone clear on XSS? Okay, let's go to SQL injection. So SQL injection is probably the #1 vulnerability in different websites. I mean, a quick example, I was just researching for this thing, and I found this awesome article, whereas I saw that Harvard was breached, was hacked. And I was wondering, well, how would they do it, right? Harvard's the most awesome, most secure university ever, right? Well, to breach a server, the hackers use a technique called SQL injection. So this happens on a day-to-day basis. People forget to take account for SQL injection. Harvard does. I think it says here Princeton, Stanford, Cornell. And so what is this SQL injection that is bringing all these people down? Okay. So SQL is a programming language that we use to access databases. What we do is we select, so what this reads right now is select everything from the table. SQL is checking into these databases that have tables full of information. So select everything from users where the name is username, right? Simple enough. The idea of SQL injection is that we insert some malicious code that would trick the server into running something different than what it originally was running. So let's say we put in for username, we put in or1 equals 1. So we put in or1 equals 1. The way it will read now, it will be select from users, everything from users is everything, where name is username, but username is or1 equals 1. So name is nothing, or 1 equals 1. 1 equals 1 is always true. So this will always return information from the users. Okay, we don't need to have the correct username. We can just have anything that we want, and it'll return the information that we need. Let's take another example. If we have select everything from user where name is drop table users. So what do you think this will do if I put in the username as drop table users? You have an idea? Yes. It's going to tell us to dump everything in the website, everything in the database. And what people use this for, so I'm going to show you guys. I disabled dropping the tables because I didn't want you guys to drop my tables. Let's take a look at this. So this simply pulls up the information for a certain person. So how do we know if this is affected by SQL injection? We're going to check real quick if we can put something. I'm going to copy this code. I'm going to go over it in a second. I'm going to put root and 1 equals 1. This right here, this %23, what it really is, if I look right here at the way HTML takes in numbers, if you take a look at when I put in a space here, if I really put a space something here, it changes it to a %2. Do you guys see this right here when I put in a space? The way it works is that you can only send ASCII values through HTML. So it replaces, for example, a space with %20. I don't know if you guys have seen that before. It replaces a hashtag with %23. We need a hashtag at the end of our statement so that we can tell the database to forget to comment out this last semicolon at the end. We wanted to not think about that. We just wanted to run everything that we have beforehand and comment that out. Let's take a look at. So if I were to put something wrong, let's say, for example, I put 2 equals 1, it doesn't give me anything. When I put in 1 equals 1, and it does return something, this tells me that this is vulnerable to an SQL injection. I know now that whatever I put after this, and for example, drop tables, or something like that, will definitely work. Okay, I know it's vulnerable to SQL injection because I know that underneath the hood, it's letting me do the 1 equals 1 thing. Okay? And if we look at these other ones, number 2 and number 3, it's going to do a little bit more of checking underneath the hood of what it is. Let's. Has anyone been able to drop anything yet? Try. Do you guys sort of get SQL yet? Because I know you guys haven't seen it yet, so it's kind of confusing for you guys. Okay, let's take a look. So what's the way to prevent SQLI? Okay, so this is really important because you guys definitely want to prevent this in your websites. If not, all your friends are going to make fun of you when they drop all your tables. Okay, so the idea is that you prepare the SQL in a certain way, whereas you match with the user input with a certain string. So the way this works is you prepare the database. You select name, color, and calories from a database called fruit. And then where calories is less than, and we put a question mark there saying we're going to input something in a second. And color equals, and we put a question mark saying we're going to input something in a second as well. Okay? And then we execute it putting in 150 and red. And this will check to make sure that these two, this array will check that these two is an integer and that this is a string. Okay. Then we go and we fetch all, we put it in red. That means we fetch all means we actually execute the SQL statement and put it back in red. Here we do the same, but we do the same for yellow. And we fetch all. And then this way, we prevent the user from being able to input something that is not what we specified, a string or an integer, for example. Let's talk a little bit about relying on others. When you guys start your project, you're most definitely going to use Bootstrap or something similar. Have you guys ever used WordPress? Probably you guys have used WordPress, most likely. So the problem with using other people's things, I'm just going to Google real quick, WordPress vulnerability. If I pull this up right now, I literally did a 2-second Google. We can see that WordPress, this is dated as September 12th. 26 is updated. The default configuration of WordPress before 3.6 does not prevent these certain uploads, which might make it easier for cross-site scripting attacks. So a quick story. Once we were working with, I was in summer working an internship, and we were working with a sort of like a big credit card company, right? And they rely on something called, I don't know if you guys ever play with a product called Joomla. Joomla is a product that is used to control, sort of like a similar to WordPress. It's used to build websites. So they had their website working on Joomla. This is actually a credit card company in Colombia. I'll take you to their website real quick. So they used Joomla, and they hadn't updated Joomla to the latest edition. And so when we were taking a look at their code, we were able to actually go inside their code and steal all the credit card information that they had, all the credit card numbers, the names, the addresses. And this was and their code was perfectly fine. They had great code. It was all secure. They checked all the databases. They made sure cross-site scripting was fine. But they used something that was not updated, that was not secure. And so that led them to. So you guys are definitely going to use other people's code, other people's frameworks to be able to build up your website. Make sure that they're secure, because sometimes it's not you the one that makes the mistake, but someone else makes a mistake, and then you fall down because of that. Passwords and PI. So passwords. Okay. Let's take a look at password real quick. Please tell me that everyone uses secure. I'm hoping everyone here uses secure passwords. I'm just letting that in as an assumption. So you guys are definitely going to store passwords for your website. You're going to make something like a login or something like that. What's important is to not store a password in plain text. This is extremely important. You do not want to store a password in plain text. And you definitely don't really want to store it in a one-way hash. So what a one-way hash is that when you generate a word, when you put this word into the hash function, it'll generate back some sort of cryptic message or cryptic set of keys. I'll show you an example. I'm going to hash the word password 1. So MD5 hash was going to return me some sort of weird information. The problem is that people out there that like to go into websites have already figured out sort of all of the MD5 hashes. What they did is they sat down on their computers and they hashed every single possible word out there until they got sort of what this is. If I were to look this up, I just grab this hash. If I get this hash if I go into a website and I find this hash, because I get to the databases, and I look it up, someone already figured it out for me. Yeah, so people sat down, and whatever MD5 hash that you put in, they're going to return to you something that is a word. If I hash another word like, I don't know, trees 2, hopefully I don't want to be disappointed by my Google searches. There it is, trees 2. So a lot of websites still use MD5 hash. They say, oh, it's secure. We're not storing in plain text. We have this MD5 hash. And all I have to do is just Google the number. I don't even have to compute it myself. I can just Google it, and someone already did it for me. Here's a bunch of them. Here's a bunch of passwords. So definitely don't use MD5 hash because all you have to do is Google it. So what do you want to use instead? Okay, something called salting. So what salting is, because remember when we were talking about random in, I'm not sure what PSET it was. Was it PSET 3 or 4? Maybe. We were talking about random. It was talking about finding the needle in the haystack. And then the PSET said that you could actually figure out what random generates because someone's already ran random a million times and just sort of form what they generate. What you want to do is put in an input. So that's what salting sort of is. They already figured out what salting returns for each word. So what salting does is you put in a salt, you put in a certain word, and it will hash that word depending on what you put in here. So if I hash password 1 with this sentence, it's going to hash differently if I hash password 1 with a different sentence. Right? It sort of gives it somewhere to start for the hashing to begin. So it's a lot harder to compute, but you can still compute it. Especially if you use a bad salt. People have already also figured out like common salts and figured out what it is. Random salts are much better, but the best way is to use something called crypt. And what crypt allows you to do, so these functions are already built for you. Maybe people don't forget that or they forget to use it. But if I look up crypt on PHP, crypt already returns a hash string for me. And it actually salts it many times and hashes it many times. So we don't have to do this. So all you have to do is send it into crypt, and it'll create a great hash without you having to worry about salt or anything. Because if you were to salt it, you have to remember what salt you used. Because if not, you can't get your password back without the salt that you used. Okay. And also personal identifiable information. So Social Security, credit card, that's pretty obvious, but sometimes people forget sort of the way it works is how much information do you actually need to find some one person, right? Someone did a study about this a way back, and it was like, if you have a full name, you can't find someone that easily, but what if you have a full name and their date of birth? Is that enough to identify someone specifically? What if you have their name and the street address that they live on? Is that enough to find someone? And like that's when it questions like what is enough that what is personal identifying information and what should you worry about not giving away? If you give away personal identifying information that someone gives you, you could potentially get sued, and we definitely don't want that. So when you're putting your website out and you have a really cool design, hopefully you made an awesome final project, and you sort of want to put it out there, you want to make sure that whatever you're taking from the user, if it's personal identifiable information, you want to make sure you're being really careful with it. Shell injection. Okay, shell injection allows the intruder to get access to your actual command line in your server. And so he's able to run code that you can't control. Let's take an example of this beautiful string right here. If we go into the website again, and we go into code injection, so what this does is it's also what we were looking at before. We're letting the user put in whatever he wants, and it'll print out. It's not, it's, oh, that was bad. Whatever he wants. So I'm going to put a call. What this does is it will start by concatenating. So it will let me run whatever command the person's running before and my command. And I'm running a system command. And these last strings is, remember what I talked to you guys about, whereas you have to encode it in a URL method. If I run this now, which is over here, you'll see that I ended up running a command. This is actually the actual server that my website is running on. So we don't want that because I can run, this server is not mine, so I don't want to mess up his server, Marcus's server. So, but you can run more commands that are that are dangerous and potentially you could delete files, remove directories. I could remove a certain directory if I wanted to, but I don't want to do that to the Marcus. He's a nice guy. He let me borrow his server, so I'm gonna let him off on a good one. So, okay, what we don't want to use eval or system. Okay, eval or system allows us to make these system calls. Eval means evaluate. System means what I ran. It's run something in the system, but we can outlaw these things in PHP so that we don't use them. And file uploads, that's going to do an awesome thing with the file upload, but like I told you guys, my file upload thing isn't working. If I were to upload a file right now, right, and it's a picture, right? I would say you have an upload thing that's a picture. That's fine, nothing happens. But if you have an upload file, for example, and the user actually uploads a PHP file or a exe file or something like that, then you could potentially have a problem. This was working before. Unfortunately for me, it's not working anymore. If I, for example, upload this file, I'm not giving permission to upload the file due to the server not being mine. So the guy's really smart. So we don't want to use. I'm going to show you guys this. Okay, these are some really cool tools. So these go into, if you guys have Firefox, hopefully you do. There's two add-ons called SQL Inject Me and Cross-Site Script Me. Okay, they open up as little sidebars on the side. And if I were to go to CS50, for example, so what it does is it looks for all the forms that, hopefully I won't get in trouble for this, but okay, here's the pin system, right? Okay, so when I start looking for holes in the system, right, the first thing I do is open up this beautiful little tool on the side, and I'm going to test forms with all attacks. And so what this does is it will slowly open up a bunch of browsers. Here's a bunch of browsers, and it's trying every single combination of cross-site scripting that there possibly is. If you see on the side, and then it'll give me a result, sort of what the answer is. I'll pass. Obviously, they all pass. They're really smart people up there. But if I were to run, I've had times before when like I run this on students' final projects. I simply run SQL inject me with all different attacks, and it's trying to SQL inject this pin server. So if we scroll down, for example, it says, this is good. If it returns, so it tested some certain values, and the server returned a code that was negative. Remove temporarily. This is good. It tries all these tests. So you could simply run. I wish I could find the website real quick that would let me, maybe CSFD store. Oh, this is going to take way too long. I let the first test not finish right, so it's complaining. So these are free things. These tools are free. You can download them and run them on your website, and it will tell you if you have cross-site scripting, if you have SQL, if you have something of the like. I'm sort of messing up. What's important? Okay, so never trust the user. Okay, whatever the user inputs to you, make sure you sanitize it, you clean it, you check for the right things, that it's giving you what you want him to give you. Okay? Always be updated on what frameworks that you're actually using. If you use something like Bootstrap, I know you guys are going to use Bootstrap because he's going to go over this soon in class. And like WordPress or something like that, normally this could be hacked, and then you don't even know. You're just running your website and it's totally secure, and you go down. So I'm finishing really early, but I want to thank Pentest Labs. I'm going to show you guys something called Pentest Labs. If you guys are really interested in sort of what security really is, So a website called Pentest Labs, if you guys go to it right now. Oh, well, that's not it. I'm just going to run it like this. Google tells me the answer. Okay. And it teaches you, so it says learn web penetration testing the right way. It teaches you, hopefully you're an ethical person, but it teaches you sort of how you can look at how you can get inside websites. And if you learn how you can get inside websites, you can learn how to protect yourself from getting inside websites. From let me zoom in because maybe you guys are not looking at this right. From SQL injection to shell. So sort of how I can get from SQL injection to shell. And it starts with, you download this virtual machine, and the virtual machine already comes with a website you're going to try it on. You download this PDF. And it'll show you line by line what you have to do, what you check. This is what an attacker actually does to get inside a website. And some of this stuff is complicated. I wish I could go over more things with you guys, but I worry that you guys haven't really, this is what I went over with you guys, web for penetration testing. Sort of don't really know what SQL is and what Carl Jackson's seminar is awesome as well. You guys don't know sort of what this is. But if you go to this website and you download these tutorials and these PDFs, you can take a look at sort of what the area of security really does and penetration testing, sort of see how you can get inside websites and protect yourself from it. So if I make a super quick overview, it'll be prevent cross-site scripting. You want to use HTML special charts every time the user inputs something. Prevent SQL injection. If you do that, you're already better off than Harvard was when they got breached. And make sure your passwords are not in plain text. Make sure you don't only one-way hash them, but that you use crypt, the PHP function that I showed you guys. That way you should be good. Also, if your friends let you, run SQL inject me on their websites. Run cross-site scripting on their websites. And you'll see a lot of these websites have a ton of vulnerabilities. It's like incredible how much people forget to sanitize their databases or to make sure their cross-site, make sure what the person's inputting is not script code. Okay? I sort of ended really early. But if anyone has any questions about anything, you can shoot me a question. Yeah, go.
Could you explain how the file upload?
Yeah.
Exactly works?
Yeah. So let me show you the file upload real quick. So the file upload. The problem with the file upload right now is that I'm gonna open the code so you guys see the code behind the scenes. And it is upload. Here's a code for the file upload, okay? We're trying to go into this directory over here. And we're trying to, once we input the file, it's set file. So when there is a file in files.image, then we try to move it here. We grab the file over here. The method is post, right? Type image file. And we're setting this file. And then once we get it, so once file has an image, we're trying to send it to this directory. The problem is that the website is not letting me go to this directory because it doesn't want me to go back. It doesn't want me to go. I have to go, so here's upload, here's images. I have to go all the way back to the beginning and put it in there, and then go and put it in the directory. Sort of if I was running a terminal window and I wanted to move a file. My terminal window key can't see it. If I want to move a file, I have to put the file name and then the complete path I want to send it to. And then the server's not letting me go back, and so it's not letting me get to that file. But normally, so this is a code for uploading a file. So normally what will happen is that the person is not checking if my file ends with .jpeg. So I would want to check. Let me open example 2 real quick. okay, this person right here, so example 2 is checking if preg match, here's over here. Preg match, make sure the end of the file ends with PHP. Okay, which is good. This is good. But there's a real big problem with this. This is good. But if I were to put a file called like my favorite picture .php .jpeg, right? I can still potentially get rid of the JPEG and run it. The .php is what's dangerous, right? You don't want the person to be able to run code on your website. But then .jpeg lets it pass this. The idea is what you really want to do is not take files, A. But okay, what you really want to do is make sure that you read over the whole word, and there's nothing .php in there. There's no .php in the whole file name.
So if you did .jpeg in the end, the server still run the PHP code?
No, it won't run at the beginning. You have to go back and try to see if you can.
Oh, you have to like, okay, there's like another step that involves.
Yeah.
Okay.
Yeah. Okay, any other questions? Okay, I'm going to leave this up and sort of try to see if you guys can. The other ones are a little bit more complicated because they require much more knowledge on SQL than just the beginning knowledge of what SQL is and what JavaScript is. But I'm going to try to keep this up, and hopefully you guys will learn about this and try to take a peek at what you guys can do and how many examples you can get through. Anyone have any other questions about it? No. Yeah, shoot. Yeah, go ahead.
Okay, so I heard about like how like magic codes are not like secure enough.
What, magic quotes?
Yeah, so it's like it adds like, so whenever you input something, it always adds quotes.
Yeah, okay.
And then like I thought that worked, but then I searched it up and it said like it's not good. But I'm not sure why.
Yeah.
Like, don't use magic codes because it's not secure, but like.
Okay, so magic quotes is when you insert SQL and then it already adds the quotes for you.
Adds like quotes around whatever you put in.
Yeah. So the problem with that is that, take a look at.
Are those required for an SQL statement? Like, or I guess no, it could be like quote select.
Yeah, you need the quotes for the SQL.
No, but like the server does it for you.
These small quotes right here, these little quotes. Yeah. The problem is that you can comment out the last. Okay, so what I can do is I can comment out. So let's sort of like, let's take a look at. Let me open the text edit file. Let me just edit this right here directly. Okay, can you guys see that clearly? What I can do is I can comment out the last one, right? This will comment out the last one, and then I'll put one here, put all malicious stuff here. So the user is actually inputting, right? The user's not inputting the things, right? What I'm going to input, this is what I'm going to input as the person trying to get inside. I'm going to put in okay, whatever. That's one quotation mark. It just squiggly by mistake. And then what the code is going to do. Sorry, let me take this out. What the code is going to do is it's going to add the first quotation mark here, right? And it's going to add the last quotation mark as well, right? And it's also going to add the last quotation mark, right? But I'm commenting these quotation marks out so that they don't run. And I'm finishing this quotation mark over here. Do you understand? Or are you lost? I can comment at the last quotation mark and take care of the first quotation mark. Yeah, and just finish the first one. Yeah, that's right. That's what I can do. Yeah. Any other questions like that? That's a great question. No, yes, maybe. Hopefully you guys will sort of make more sense when you study SQL and things like that. But make sure you keep these tools in watch. Sorry, these tools over here. These tools are great. If anyone has any questions, you can also email me. This is my normal email, and this is my work email, which is when I work at C's. Okay, thanks. Thanks, guys. You're good to go. You don't have to stay here. Don't clap. That's weird. Okay, thanks, guys.